Hi, my name is Anthony Slewin. I'm the director of the Data Science Discovery Program at UC Berkeley. We're here to talk about Jupyterhub and think about this as a California-wide kind of initiative. Let me see. We have a great group of panelists. Let me just start with a quick intro. Essentially, we have 4 panelists today. One of our panelists from UC Davis is currently now available due to a family emergency. But how about each one of you introduce yourself really quickly about your role. Then we can talk about the setup of your systems later on. You want to go ahead?
Hi, everybody. I'm Shane Knapp, UC Berkeley Data Hub Technical Lead.
I'm Ben Winjum. I'm a computational and data research specialist from UCLA.
Hi there, Adam Tillman. I'm the Jupyterhub and machine learning platform service owner at UC San Diego.
And I'm Ryan Lovett. I manage computing for the Department of Statistics at UC Berkeley, and I also contribute to the campus data hub.
So to start off, how many people here know about Jupyterhub or have hubs in their universities? Okay, so everybody, you came to the right place. So we don't have to explain it in a way, but maybe for the audience virtually, maybe we can just, does anybody want to explain why Jupyterhub is so significant for their campuses and education and research work?
Yeah, one really important thing is that it provides a compute platform for people that may not have, a very powerful laptop or things like that. It also allows instructors to come up with very unique and customized environments for their courses. So for instance, an economics class could have a specific image with certain Python packages, and then something like civil engineering, which uses QGIS, they might need a graphical interface, but we can still provide that on a Jupyterhub.
Yeah, and just to kind of tack onto that point too, one of the first use cases at UCLA was enabling a research group that had very sophisticated homegrown research codes to be used as tools for students. So they didn't want the students to have to compile their own codes inside the environment. They just provide an environment as well as kind of a well-curated set of notebooks and educational materials for them to use the codes.
At UCSD, I think we've seen, certainly in our lower division introductory classes, the ability with Jupyter to commingle the text and as well as programming content has been useful. And I think with Jupyterhub, we don't have the expectation that students or faculty need to manage their own environments. They can create it once, we can create it once for them, and then they can get on with their teaching or their learning.
Yeah, so regarding Jupyter itself, so I started back in the day when people, in order to do their research computing, you would use a terminal. You would start up some sort of program like R or Python or SAS or something, and it would present you with a read eval print loop, and that's fine. But users nowadays love their web browsers, and you just open your web browser and you can get going. It's very simple. The other thing about Jupyterhub is that we can deploy things other than Jupyter. Now we can deploy other web apps like RStudio or VS Code or anything that can be proxied as a web app. We can deploy fairly easily.
Great. Thank you so much. I think for the next part, we're going to go over a quick overview from each individual university about their own Jupyterhub setups, because I think, I don't think there's a central place where this knowledge is shared across all the UCs. So let's start off with the Berkeley deployment. Oh yeah, so these are the basic questions, whether they support education, the number of users, the kind of the technical infrastructure, the amount of what cloud provider they use, on-prem or Google or Azure, and even the administrative aspects. So we're going to go over all these questions very quickly from each UC. So to start off, does Shay from UC Berkeley, do you want to talk about the Data Hub or?
Yeah, sure. So we have a very, very large deployment. Sorry, my voice is loud, but this is better. We have a very large deployment at UC Berkeley, and in fact, all faculty, staff, and students are allowed to log in and use it. No questions asked. We do a little bit of research as far as I know, but not too much in an official capacity. Currently about 79 courses use it, over 12,000 people semester log in. We're fully on GCP and we're managed by about 1.2 people. It's a little crazy, but it is what it is. And then, the big one is that we have so many different unique hubs for everyone, and we work really closely with the instructors to come up with new ideas. So thank you.
Next is another UC Berkeley data hub that's separate from the main instructional data hub. Ryan, do you want to go ahead?
Sure, yeah. So at around the time I started on the main data hub, I was just really seeing its value, and I wanted to bring it to my departmental hubs, where we have a Slurm cluster. Slurm is a batch computing system for small HPC clusters, and it's fairly easy to put Jupyterhub in front of that, and that gives our user community a lot of value in terms of interactive computing. We're all research at this point. I sort of redirect all of the classes to using DataHub, and yeah, our HPC nodes have things like GPUs in them, and they could start their jobs on them. There's a small number of tools that could monitor the status of the GPUs and whatnot. So yeah, it's just for a really good user interface on top of an existing platform.
Thank you. Next up, the UC San Diego.
Yeah, so our Jupyterhub is built upon similar to Ryan, a compute cluster that was already in existence. This was a machine learning oriented compute cluster based on Kubernetes. We built that out around 2016, 2017, and had a separate Jupyterhub running up in Amazon. And we realized pretty quickly that the folks that were submitting their batch jobs or even kind of interactive CLI jobs within that Kubernetes cluster also were very interested in Jupyter. And so we decided to merge those together. We brought the Amazon Jupyterhub into the machine learning environment. And then from there, I think it's really the Jupyter usage that has really dominated as far as we can tell, and certainly on the instructional side. Our cluster is used for both research and instruction. Our research IT team, their facilitators, will set up researchers within the what they call the research cluster, which is really just a co-branding of our Jupyterhub and our machine learning platform. And we have a couple hundred researchers in there right now at various levels. They view that cluster and the Jupyterhub that it's tied into as a way to address the long tail. We have people, who can go apply for national resources and run their code there. But some people just need a few CPU cores or maybe one GPU for a little while, and it's really hard for them to find that anywhere else on our campus or online. And then on the instructional side, we support about 130 classes a year. That keeps going up. We're seeing about 10% growth each year. And then about 16,000 separate enrollments over the course of the year. And that's in departments that range from data science, where kind of everything started. We've got music coming in and using our Jupyterhub, and we've got physics, astrophysics that's now running on it. And so we're really seeing adoption across basically every corner of the university. And I guess, like I mentioned, this is an on-prem cluster, and I think that's probably a little bit different from the rest of the folks here. And that means the kind of the costing and the money behind it is radically different than a cloud approach. But because of the initial heavy use of GPUs, the calculations pointed towards keeping it on-prem. And so we just try to keep it as busy as possible.
Cool, thank you. Next up, the UCLA.
So the UCLA Jupyterhub that I deploy is primarily used for education. It's used on the order of between 5 and 10 classes a quarter, a couple hundred up to 1,000 students. So it's used in departments ranging from physics and economics and a lot of the sciences to digital humanities and people from the School of Business. It is deployed on the cloud. Initially, when I deployed it, it was deployed on the sandbox clusters at UCLA, but it was more advantageous to put that onto the cloud. Another set of Jupyter hubs actually that I maintain is related to a specific research project at UCLA called the UCLA TAL project. That's the Teaching and Learning Laboratory. And they have a course kata online digital book program responsible for teaching statistics and data science. And that particular Jupyterhub is taken advantage of not only by classes at UCLA, but a variety of Cal States, community colleges, and also high schools, kind of all across the greater Los Angeles area. And so there are a couple of tools that have been developed in particular for that, integrating a dashboard with Canvas and developing a particular API, which makes it easy, for example, even for high school teachers to distribute and collect assignments from students. Yeah, so that's the basics of the UCLA deployment.
Right. Thank you so much. Unfortunately, our Davis guest again can make it. But his work is really interesting. It's for covering, I don't know if you can check out LibreText, I believe. And so there's a very innovative stuff happening at Davis. I urge people to check it out. The person, Delmar who is? Larson, yeah. So, okay, so this slide is kind of a collection of information we have so far. We're missing a few other UCs, but we're trying to consolidate what's happening across this very diverse ecosystem of different platforms people are using to run Jupyterhub. And you can see the different staffing and other models of how each UC does it. But I want to start with the panel conversation with probably the most important question that everybody's facing, funding. Who wants to start that conversation? Yeah.
So UCSD had, I guess, back in 2015 and 2016, back when actually, I think in response to Berkeley's Data 8 program, our faculty became keenly interested in taking that same approach. And so they came to IT services and asked us if we could basically build what Berkeley was doing. And then at the same time, and that's what led to our Jupyterhub, but that from the start, we had very high level kind of executive level support for that sort of activity. And then at the same time, that machine learning cluster had similar support coming out of our one of our engineering research units. And so I think it was that high level support that was able to get us some of the initial funding, both for capital equipment, the hardware that we're running on, but also get us a couple of positions carved out full-time to handle this work. And so right now within our academic technology integration unit, we've got two people whose positions are essentially focused on the technical management of our environments. Now we've got many other people that are handling the day-to-day, this student needs to have access to this class resource and that sort of thing, or even the faculty intake. But getting those two positions was really key, and I know how hard that can be.
Yeah, so that's interesting that you saw what we were doing with Data 8 and decided you wanted it for yourselves. So yeah, it's pretty cool. Yeah, so here at Cal, we actually have a big problem with staffing. So the Data Hub project was kind of a hackathon for the last few years. And then the technical lead, UV Panda, he decided he was done. He wanted to move on. So position opened up and I just happened to be wanting to move on to a new position at Cal. So I took it. Boy, I had no idea what I was getting myself into. So yeah, I mean, we literally have I'm 80% on Data Hub, and then we have two other people at 20%. Balaji here, where he's about 20% technical, but 80% service lead, non-technical, and Ryan volunteers. So yeah, we're trying to get funding together for staffing. We're not quite sure how we're going to do it. It could be a course fee. It could be a student fee. The way that our project is funded is very strange. The College of Data Science pays for the cloud. Research, teaching, and learning pays for the staff. So making sure that both of those completely different units are talking to each other and on the same page with regards to Data Hub is highly important. So Balaji and I have been doing a lot of work over the last few months in trying to track all of the projects, all of the bugs, all of the features that we would like to add. And we're going to, for the long story short, put together a list of what we couldn't do in a year give that to leadership and say, if you want this to really shine as a product, if you want this to be sustainable, because I don't want to be doing this for the rest of my life, we need staffing, full stop. So it's been a challenge. We're really lucky that we have a pretty stable system right now. It wasn't when I took over, but we made some changes, and specifically Google File Store was a big win for us. So yeah.
The support at UCLA is kind of going even more in the supporting ourselves by the seat of our pants. Initially, I started out at UCLA. My supervisor just asked me to investigate what this thing called Jupyterhub was. And I tried to set it up on one of our sandbox clusters. So I took advantage just of some computational resources in our on-prem systems that weren't being used at the moment, and used those to support the Jupyterhub use for a couple of years, and take advantage of what everybody else was posting for issues on GitHub or putting out as documentation for the Zero to Jupyterhub project. There are a couple of other people at UCLA who have developed Jupyterhubs as well, although I end up being the one at the moment who supports the deployment. It's just myself, and it's only one of my the duties that I carry out. I have a lot of other duties with the high performance computing at UCLA. So we're also kind of in a situation where we need to figure out the funding for any staff who's going to support this. At the moment, deploying the resources on the cloud, we've been able to take advantage of the fact that I provided technical support to a particular PI at UCLA, who was then gracious enough to allow us to take advantage of his cloud account for running the Jupyterhubs that we now use to support some of the classes at UCLA. So we're also in the mode of trying to figure out how we would support the cloud compute costs, and trying to just sort it out, because we think it's definitely a big advantage to make this available to classes at UCLA. We just need to figure out how to make this more sustainable.
Yeah, I guess my situation is a bit more straightforward. I work in an academic unit. Research IT is just considered part of what we do. So we're on permanent funding, and so I can, yeah, I guess I don't have to worry. Knock on wood.
So jealous, so incredibly jealous.
Yeah, our facility is 30 years old, and so if I think the creators of our facility just knew that statistics was going to be at the heart of something called data science, and just realized the value. So they were able to convince somebody a long time ago to support research computing, not to put people on soft money, and we are benefiting. Yeah.
Great. So to recap, everybody has a different story about how they get funding, and it seems like no one has a clear solution for the long run, right? Do you folks want to delve in that a little more? What is kind of a solution for the long run?
Well, one of the things we're looking into is calculating how much it costs per student per course, or per student per department. So this has got some very clever labels within GCP and Kubernetes, so we can start tracking, say Data 100 has X number of students, their daily spend is this, their file store spend is this. Do we start reducing storage? Do we start, giving them more compute? And then this will kind of give us a story for going up to leadership and saying, hey, this one course is costing us $25 per student per day. Can there be a course fee to help offset that? And then that's one of the many myriad things we're looking into regarding funding. So
we're going through the same exercise right now, but prompted by some self-supporting graduate degree programs having interest in using our facilities. And for those, we have to compensate or pull back whatever funding we use to support them. And that's not just the marginal cost, that's the total fully loaded cost. And so we've had to go through those calculations. And I think that's going to help us even internally, because with the growth rate that we've had, it's been hard on our staff to support 50 classes a quarter, and try to figure out how to give each one of them the personal attention that I think we had established as an expectation in our faculty early on. With our pilot customers, we could roll out the red carpet for them. And now that we're handling so many faculty, we really need to decide what level of service can we give them, how much analysis of their curriculum and how much of the coding can we do, right?
Yeah, and another thing we're doing at Cal is we want to start supporting more research. So my previous position, I was working in computer science graduate research labs, and they're like GPUs. They just consumed as many GPUs on the cloud and on-prem as possible. So when people approach me and say we want to do research on a Jupyterhub at Cal, we have to okay, first off, define research. Like, what do you mean by research? Is this like language models? Is this something in econ, or is this something in like the demography department, right? What kind of resources does this type of research need? And then figuring out the types of guardrails we could put up around this resource usage. And then that goes straight back to funding, because research is going to, by definition, always cost more than regular academics. So we don't have any answers to this yet. We're just starting to have these conversations. I would love if anyone has any input, because that would be super, to deploy this in the most easiest way possible for the DevOps teams to manage. Having multiple billing accounts is one, but then that just gets into its own cloud of nightmares right there. So
just kind of to add something. So we had all introduced ourselves to each other before the meeting. And I think one of the advantages of meeting each other too is we'll be able to collaborate on questions like that, and try and just monitor the usage of students or whoever else uses our Jupyterhubs at the different institutions, try and find some good metrics to try and keep track of the usage, of the costs, of the different needs that we provide as far as service goes for a certain number of classes or a certain number of students, all that sort of stuff.
So the next question I want to follow up with is discussing the issue of staffing, which is related with funding, of course, but is looking at the chart, we can see like many institutions have shared staff or only one staff member to do something. So do people have thoughts about finding staff to do this and the workload? Any thoughts?
I've got plenty of thoughts.
Okay.
I mean, it's kind of a conundrum here, because we need very technically savvy people to understand GCP or whatever cloud provider from the ground up, understand how all that works, understand Python, the Jupyter code base, know how to work in an open source environment, creating pull requests, feature branches. And, we had 250,000 people laid off from the tech industry in the Bay Area in the last year and a half, but we don't have the money to hire any of them. And if we did have the money to hire any of them, we couldn't offer anywhere near the salary. So it's going to be tough, so we're looking at hiring some undergrads to start doing some of the base operation tasks. We're actually, one of the 20% people is working on some tooling around that, which is going to be great. And that'll free up a bunch of our time. But yeah, it's going to be hard to do staff. It really is.
I think we've been focusing on trying to automate as much as we can, just as you, to try to reduce that burden, and maybe preserve our core staff for keeping the platform running or keeping the service running, and then bringing in students, either undergrads or grads, to help build out the custom environments that individual faculty might want. And we're really promoting our faculty to try to find somebody in their area who can get up to speed on these technologies. And maybe it's somebody in their lab, and they can just, it can be kind of a side business for that student, for that grad student in their lab, or somebody that the department funds. We're not very far along in that plan, but it's a direction that we're hopeful can help relieve some of the burden as we keep growing and growing the number of users on the platform.
Actually, to tag on that, so we've had this idea of training up some of our TAs and some of our instructors in the more technical classes to be able to help manage their environments. And for instance, Data 100, we already have all the TAs and all the instructors filing pull requests to add packages to the environment. We're working with them on how to do testing, and they love it. They love being able to make their own PR. They know exactly what package they need. They know how to do the testing locally using repo to Docker. And it's been great. So we're like slowly reducing the amount of the day-to-day grind via that and automation.
And there could be advantages to students as well, because maintaining an environment like this will require that they become familiar with cloud computing, managing a Kubernetes cluster. What does that mean? If we do continuous integration, how do they handle the continuous integration? There are a lot of advantages to the students. I mean, it requires a lot because you'd have to teach the students a lot of things. If we're talking about a UC-wide, what does it mean to have a UC-wide Jupyter Hub, or in what sense do we think of that? I think it would be useful to share our, the configuration files, the things that we do as far as the continuous integration, various sorts of complicated, infrastructure support that we have to carry out. That it would just be useful to share knowledge about how we do that.
In terms of making things easier for staff, I think what we've learned is it's just best to make things as self-service as possible for the instructors. I think they like that because they're just more in control. They can do it immediately. They don't have to wait for us. One thing that we're sort of looking forward to is the ability for them to build and make their own Docker environments. So right now, as Shane was saying, they could, make PRs and whatnot, but there's a service that maybe some of you are familiar with called Binder, where which people use to make reproducible computing environments. You can specify your own Docker image and it just sort of builds it for you. And so that's something that we're hoping to adopt when it's available. But yeah, just the principle of giving the instructors all the tools that they need to do so that they're not waiting on us.
Yeah, and just to follow on to that, we've been heading in that particular model over the last probably 6 months or so. We had some staff changes that really forced us to radically shift the relationship that instructors had with their environments. And so we are now setting up GitHub repos and Docker files and the like, and giving them access, giving their TAs access, and then using GitHub Actions, we are rebuilding those containers, and so they have complete control over what's in their environment. We have a number of faculty for whom that is far too much to ask of them, and so we need to think about training. We need to think about ways to develop their skills. But for some of our more challenging classes, it's been a godsend to be able to hand that off to them.
I have another question regarding infrastructure. Do people want to spend a few minutes talking about why people are using on-prem versus GCP versus other cloud providers?
You are so lucky that you have an on-prem cluster with GPUs that you can just drop into. So jealous.
Am I though?
And you too. Both of you.
I couldn't tell you were looking at it. But
I'm looking at both of you simultaneously.
yeah. I mean, yeah. So seeing both sides of things, I do have to maintain the local cluster. I have to worry about what happens to the primary AC, the backup AC, the UPS, whatnot, the networking, all of that. But we can't scale, we can't scale to the size of these programs. So it was interesting walking through all the different, when we first started, the first instance of Datahub was an on-premise cluster. Then we went to Azure, and then we went to Google, and that's worked out well for our infrastructure. I do think there's a place if we can have research computing jobs that are always running on nodes, then I do think that having our own infrastructure makes a lot of sense. So, yeah.
Yeah, we've definitely seen that the regular kind of the cycle of instructional usage, which peaks around, for us on the quarter system, weeks 8, 9, 10, and finals week. That's offset quite a bit from either publication deadlines or conference deadlines that our researchers are targeting. And so we have been able to kind of fill in those gaps, not as much as we'd like. We have idle cycles during quite a bit of the year, and we would love to find a way to fill them. I think one advantage of the of on-prem hardware continues to be that you can strictly constrain your cost. You can get, you buy something and then you try to get all that you can out of it. And yes, we are leaving cycles on the floor right now, and we would like to fill them. And so our per hour cost is not as cheap as it could be if we could derive that additional benefit. But I think even with roughly 50% utilization, we're still quite a bit ahead. And mostly that is because of the GPU aspect. Without the GPUs, I don't know if there's really a case for on-prem hardware, given what's available in the cloud.
Any more? Oh, so last question before we move to audience Q&A. What does the future hold? I think you guys mentioned across your different institutions we can share best practices, but how do we further collaborate? What is the potential of larger UC-wide infrastructure, if you will? It's a very abstract question, but I think
I want to learn more about what's happening at UCLA with Canvas and Jupyterhub. I think we probably all have some experiences with our faculty and incorporating Jupyterhub into the kind of the bureaucracy of running classes and collecting grades and things like that. And it would be nice to maybe if there's some development work that could benefit the whole system, maybe pull together, make a case and find somebody that can help contribute to that.
Yeah, I'd be happy to talk with you about that. I think that, and everybody else too, that's definitely one of the advantages, I think, of being able to meet and talk with each other. We're all kind of working in our own institutions, and we might do things our own way, or we might have developed tools. So there are a lot of duties for any of us to keep track of, and we might not necessarily contribute them back in a way that's publicly accessible or just well documented. So having a community where we can just talk about these things, or have the freedom just to ask questions of each other, that has a lot of benefit. Just to sharing the tools, which otherwise just take us a long time to distribute publicly.
Yeah, and one thing that the first thing I did after meeting everyone on our Zoom last week was create a Slack channel on UC Tech, so we could at least start chatting about things, because we keep mentioning the Canvas integration with Jupyterhub. It's an iframe with a notebook in it in the Canvas course, and it is amazing, and we all want it. So, I mean, it literally couldn't have been a better time for us to meet. So.
So one comment about this too is that isn't totally my development. But it's involved my working with additional research project at UCLA for this this online book project, which also reaches out to community colleges and high schools. So I think there are other communities too, which might not necessarily be part of the UC system. I don't know that we want to talk about it here, but not just to have a UC-wide system, but to have a discussion about the wider community college environment, or the Cal States, or even high schools. I know high schools would have a lot of benefit from providing an easy computational environment to their students. So that this, I think, could this scope could even be much wider still.
Any other thoughts before we move to audience Q&A? Well, we have only 10 minutes left, so anybody in the audience have questions? Oh, Mike.
First of all, thank you all for a very enlightening conversation, and I would love to be a part of that Slack channel if that's possible. I'm Sarvani from University of California, Merced. We have recently gotten an approval for an undergraduate data science program. So as a part of it, we just started with a pilot Jupyterhub instance to help get our instructors started with using Jupyterhub. One of the challenges is, of course, integrating the existing hub with Canvas for a full implementation, and also understanding like what is it that your staff help the instructors with? How are you training the instructors, and what's the extent of support that your staff provides to these instructors?
So as far as support, it depends a lot on what the instructors are already familiar with. Sometimes with instructors, I'll even just have to explain a Jupyter notebook and try and convince them about, why is it useful to create a Docker image, and so that they have an environment which has this specific version of Python and specific packages installed in it, so that you provide a well-controlled environment to your students. So sometimes you need to explain things from the ground up. Sometimes, it can be a fair amount of work for the instructors to develop Jupyter notebooks too. So sometimes there's just a little bit of orientation to the instructor in terms of, providing them with examples of how people have developed educational materials before for the notebooks. With the UCLA TAL project, they actually keep a rather well-maintained and curated set of example notebooks that instructors can go to and access for their own classes. So they just go, the notebook's already there. We already have the Jupyterhub environment for them. They just, all they have to do is decide which notebook they want to use in their class and essentially click on a button so that it distributes it to the students. So that is even that's like the ultra easy example, and that's like for the high school teachers, who they don't need to spend time developing these notebooks. They don't even really want to teach programming to their students. They just want the students to be able to execute our examples as an example of doing computational statistics in their particular case. So it kind of runs the gamut. I'm not sure that helps you out necessarily, but it gives you an idea of some of the cases for us.
Yeah, it all depends on the instructor you're speaking to. You can have someone from the fine arts department who doesn't want to know about Git. You probably don't ever want to show them Git. And then you've got Fernando Perez, who is a core contributor to the Jupyterhub project, who also happens to be a professor of statistics here, who runs his own Docker images, builds his own Docker images. He's so technically savvy, it's almost a problem sometimes. So it varies completely.
So we maintain a set of base images that we create to try to cover most common use cases. We've got one for just basic data science. We've got one for machine learning with CUDA libraries and TensorFlow and that sort of thing in it. We've got a few others. And our model is now that we will offer those and fully support those. We will give people pretty much as much time as they need to get up to speed on those. If they want to customize further, they need to share the load with us. And so as of really spring quarter, we are now asking them to schedule consultation sessions with us. We will work with them side by side, pair programming style, to get it done. But we want some of that knowledge, our knowledge, to rub off on them. And it's through that we'll help them if they want to add a package and they don't know how to add a package to a Docker file. We'll help them with the hope that eventually they will figure out that they'll just do it themselves. It'll be faster, and then they'll be self-sufficient.
Yeah, one final quick comment. So all of our images are publicly available on GitHub. So I can share the link at some point. You can go take a look at the environment files and see kind of how we do things.
Regarding the question about Canvas integration, so there's basically, without going too far into the weeds, which I sometimes do, there's basically two ways of doing that. There's the LTI authenticator, which I believe UCLA might be using, and then there's the Canvas O authenticators, which is what we use. And so the one difference is that when you use the LTI authenticator, you go through your Canvas instance. So the students visit Canvas and start their notebooks there. With the Canvas authenticator, you go to the hub and you go through a Canvas auth there. And what that involves is, at least on our side with the Canvas authenticators, you need somebody who has access to the Canvas instant to set up some things there. What it gives us is, of course, authentication. We can also leverage the groups so that when somebody logs into our hub, we know what courses that they're in. And we can also, the instructors can go into their course and create groups. Create their own groups, and it could be for like an assignment or for throughout the semester. And so we are aware of what those groups are too, and we can use them to do things like change the amount of RAM that we give to a certain number of students who are in those groups. And we can also use it for authorization. So we can say anybody who signed up as a TA or the teacher of a Canvas course gets certain kinds of scopes, which can let them start other students, other account servers, or we can limit it to, they can only start the servers of people in their class or manage it in that way. So there's all sorts of features there. And yes, this was a very weedy answer, but I'm happy to answer more questions in Slack. Yeah.
Other audience questions?
Hi, I'm Derek. I work with Sarvani. I have a question specifically for the two people who are supporting vast numbers of students with not very many staff. Tell me about your, this is a weedy question. Tell me about your automated onboarding process. Or not, as it were. Tell me about your onboarding process.
Okay. And are you thinking specifically of students or of the courses?
Actually both, because you both also support large number of courses. So this is a little bit related to the self-service with courses, but just since you don't have enough people to meet with 12,000 students one-on-one, how are you getting all of these somewhat self-service students onto the hub into their various courses?
Okay, so for the courses, just very quickly, we now have a ServiceNow forum where the faculty members can select which environment of those base environments they would like. And through some API calls to a backend server, their course environment is now set up automatically just via API from the ServiceNow. And then we load our student rosters just straight out of the SIS into those environments to associate them, not going through Canvas, but something quite similar. And so as long as they can authenticate to our university shibboleth, they come in, and then our Jupyterhub will present them with a list of container options based on what courses they're in. And we can more on that on the Slack channel.
We have to move to maybe one last question. Yeah.
Thanks. There's actually a question. One of you does Google Cloud and ML, but I'd be interested in, was there a machine learning? Anyway, the question would go for everyone. I'm most interested in Google Cloud, but I think it would go for Amazon as well. So Google Cloud offers anybody with a academic affiliation $450 of credit to use their ML services. Looks like you might know what's coming next. You have to put down a credit card. There's a free tier that people don't exceed. And I just feel like this stops all, especially undergraduates. I don't want to I do workshops. I'll demo it. I just can't recommend people put a credit card down for something that they might exceed. I was wondering, is this something you can offer people? Can you offer them the guardrails? So, yeah.
Yes, we and we do that for Amazon. I'd be happy to talk about that later, but I've heard some good news from Amazon's leadership that they're interested in facilitating that sort of usage, not so much the canned kind of vocational training that they've really been focusing on lately, but helping students come in and start computing with those guardrails.
Unstructured learning, because you can use the tutorials without a credit card, but you're limited to the tutorial.
Yeah, so academic credits across all cloud providers, like here be dragons, like stay away if at all possible. Azure, you don't get the same level of service that you would say for like if you actually put a credit card down. GCP, yes, you have to put a credit card down. Amazon, you have to put a credit card down just to get those credits. So and then reconciling credits with the billing account is even more of a nightmare. So yeah, so we haven't, I did a lot of credits when I was working in the research groups, and then I moved to DataHub, and now we're just on a straight up billing account. And then the next thing.
Yeah. We have to wrap up.
Okay.
Yeah. Connect with them on their Slack channel. And unfortunately, our time here is up today.
Let's give an applause to our wonderful panel. Yeah.